Here we look at the hydrolysis of esters. Hydrolysis means breaking bonds using water. So we're going to break a bond within this ester using water. And the ester we're going to have a look at is this one here. This is methyl ethanoate. And I'm going to hydrolyse this. I'm going to colour code my water for this specific reaction. That's my H2O. I'm going to specifically break this bond. And this part of the molecule here is going to add this blue hydrogen. So this here will join together to form methanol. And this part of the ester will add the green OH. So this here together will form the carboxylic acid. So the products we would form then would be, if I have methyl ethanoate, I will form ethanoic acid. And I'll form methanol. So we can see there, hopefully from the colour coding, what's going on in this reaction. We're breaking the bond, the single bond between the carbon and the oxygen. The OH from water is going to add to this blue highlighted part of the ester to form the carboxylic acid. The hydrogen is going to add to this yellow highlighted part of the ester to form the alcohol. This is the reverse of a esterification reaction. Obviously, we've looked at the acid plus the alcohol forming an ester plus water. This is just the reverse. So hydrolysis of an ester is the reverse of esterification. Now, ester hydrolysis can be done in two ways. And the first one is acid catalyzed hydrolysis. And this acid we use is either dilute sulfuric acid or dilute hydrochloric acid. It's going to be a strong acid. So let's have a look at an example. So again, the bond that we are breaking is this bond here. The bond between the carbon and the oxygen, this carbon single bond oxygen, which in the structural formula is between the two oxygens. This part of the ester is going to be used to form the alcohol. This part of the ester is going to be used to form the carboxylic acid. Now, we add H2O. The key with acid hydrolysis is this reaction is reversible. I'm just going to put H plus, and this is either dilute HCl or dilute H2SO4, and that is going to form then my acid and my alcohol. So we can see that this part of the molecule highlighted in blue is where has come from the ester, and this part of the molecule highlighted in yellow has come from the ester, and we can see that I've added my H2O there that I've highlighted in green. So that's the acid hydrolysis of esters. We can also hydrolyze esters using a base catalyst. So we're going to look at base hydrolysis, base catalyzed hydrolysis. And for example, let's have a look at this molecule here. So this molecule here, well, again, we would split the ester there. This part of the ester is going to be used to make the alcohol. This part is going to be used to make the acid. Can we name this ester? Well, again, we can see that the first part of the ester name is derived from the alcohol, which is 1, so it's methyl. And then I've got 1, 2, 3, my longest carbon chain, but I've got this methyl group attached. So this would be methyl propanoate. Methyl propanoate. In the base catalyzed hydrolysis, we add sodium hydroxide. And the key here is this is not a reversible reaction. So this reaction now goes to completion. And hopefully we can see what we're going to form. This time, instead of adding the OH to the part highlighted in blue, we're actually going to add ONA instead. So this now becomes ONA. So let's colour code this using the highlighter. So this is the bit that's come from the ester, and that has come from the sodium hydroxide. And I also form methanol. So this bit in yellow is what's come from the ester, and the green there is from the sodium hydroxide. So we can see here we get a sodium salt rather than a carboxylic acid. And if I was going to name that, you've got to think, what would the acid be called? Well, the acid would be called methyl propanoic acid. Instead of calling it methyl propanoic acid, we now call it sodium methyl propanoate. So methyl propanoic acid has become sodium methyl propanoate. And the ester, remember, was methyl propanoate. So that is the hydrolysis of some simple esters. We're now going to have a look at the hydrolysis of a cyclic ester. So consider the following ester. So we've got a cyclic ester. In fact, I'm going to make this a little bit more difficult. I'm going to put a methyl group here. So if I was going to hydrolyse this, what would my structure be? Now, if I hydrolyse this, and I'm going to just use an acid catalysed hydrolysis for this particular reaction, we would split this bond. And we're going to add a hydrogen there and an OH here. Now, the structure of the molecule formed is easier to figure out if I number these carbons. So carbon 1, 2, 3, 4, and 5. So the first thing I'm going to do when we're looking at this, the product of this particular reaction, and it's, as I said, it's going to be acid catalyzed, so it's reversible. Let's have a look at the carbonyl carbon. We'll call this carbon number 1. This has added the OH. So this bit is from the water. This OH is from the water. Now, the only bond that we've broken is the carbon single bond oxygen. So everything else should in the molecule should still be as it was. So carbon 2, 3, 4, and 5. So we had 5 carbons. Carbon 5, you can see, had an oxygen bonded to it. So it's still got an oxygen bonded to it, but that now has gained that hydrogen from the water. Now, again, let's keep numbering it. We've got carbon 1, 2, 3, 4, 5. And we can see in the cyclic ester, we had a methyl group on carbon 3. So that stays where it is. And I put a methyl group there on carbon 3. And the rest of these are hydrogens. So that's how you would do an ester hydrolysis using, if you were hydrolyzing a cyclic molecule. The key is number them. And again, if you've got anything like a methyl group attached, again, if it's on carbon 3 in the ester, it'll be on carbon 3 in your hydroxy acid. And that there is the hydrolysis of esters.